Hello everyone, my name is Joshua and I'll be solving this HackerRank problem, snakes and ladders, the quickest way up. This was found in a Facebook preparation document, and how did I know that? Well, let's just say I prepared for a company that I wanted to join and I gave it a good shot. Sorry about that. Anyways, here's a basic overview. So you start from square one and you want to land square 100. That's the premise of this game. If you land on the base of a ladder, like a starting square of a ladder, you had to go all the way up to another square that's closer to the goal of 100. Now, if you land on a snake, a square for a snake, you had to go start there and you go down and you end up being a little bit farther from where you want to be, which is square 100. And now you have the special ability that if you roll a die, it could be from 1 to 6, but you could choose what number it wants to be. So with that in mind, you have to find out if you're this person who could roll a certain number of times to go to 1 to 100. What is the minimum number of moves or rolls required until that can happen? And what you'd be given this function to code out, quickest way up, and you'd be given two inputs: ladders and ladders and snakes integer array, and it contains the start and end so numbers of each ladder and of each snake. Now, there's some constraints to keep in mind. The N and M, let's see what does that stand for. N stands for the number of ladders, M stands for the number of snakes. So we know that there are at least 15 paths, per se, or 15, a size of 15 for each of ladders and snakes. And neither square 1 or square 100 will be a starting point of a ladder or a snake. So, but it doesn't specify, it could be an endpoint, so keep that in mind. And the board is always 10 by 10, so it's always guaranteed to be from 1 to 100. And the square will have at most one endpoint from either a snake or a ladder. So there could be multiple paths. Oh yeah, so I don't think there'll be a chance where one path will have like 3 paths. It could be, that would be either both a snake or a ladder or a snake. It could just be, it goes from one direction to another. I think there's an assumption also that an endpoint could share, there could be multiple starting points that could have that shared endpoint. So maybe that's a possibility to think about. All right, and also, so we have to find the least number of rolls, like I mentioned, and if there's no solution, we print -1. And here's a sample input. You feel free to pause and think about this, and here's a sample output. Oh yeah, here's a good explanation. So you could either roll whatever you want. In this case, you could roll 5 and 6 to land at square 12, and then it has a ladder to 98. And then you could roll a 2, and therefore you could have this done in 3 rolls to go to square 100. This is a lot of information to input, so feel free to pause and think about this question. I'll even try to include the link to this problem below in the description. But I'll just go right to it. So my first instinct, this is sounds like a BFS question, a breadth first search. So what a breadth first search does is that it's basically, it could graph multiple possibilities of how you can roll it to reach the endpoint. So let's just say that you need almost a queue that could keep track of your current position. Oh yeah, track of current square possibilities. Because here's how it works. Once you could roll from 1 to 6, you'll be given 6 possibilities of starting from that point. And when you roll, you could go to a new square, basically. Track of your current square possibilities with each position. Okay, and we'll definitely need some sort of hash map. So one thing to keep in mind is that, if we have 6 possibilities and we roll it again, we can't have any repeat possibilities if it was a shorter path already taken. I mean, there was already a roll that already took that position previously. So we need a map, or maybe specifically a hash set that checks taken positions already, so we don't have any repeats. So this queue keeps, so if it's not repeated, we put it into the queue that, this is where the position of the person is, and ready for the next roll and turn. Oh, here, maybe I'll go step back a little bit more because it's kind of, I think I'm going a little too fast. when you're playing the game, you're thinking about the number of possibilities of how you can get to the end. So when you roll, you could roll a possibility of up to 6 possibilities, whether you can of where you can be in that certain position, and then in that position of, so you have 6 possibilities. With each of those 6 possibilities, you need to find another 6 possibilities. It could be up to 6 possibilities of where it could be when you roll it again. But there'll be times when they'll share that same position, but it could be achieved earlier. Like, let's just say your first roll can reach position 6 slower than when you could just roll a 6 right away. Therefore, you don't really need to keep track in the queue of that possibility. You only want the fastest possibilities, because our goal, to remind you, is to find a minimum number of rolls. With that in mind, I think we need to keep a counter of the minimum number of rolls. Okay, we have the queue, the hash set, and we also need a hash map of all the shortcut paths, which is from snakes and ladders. Okay, so let's go through each step. 1, start with space 1 as taken. Okay, step 2, find possibilities of end roll with given spaces. 3, if now, so when I say possibilities of end roll, I say position possibilities. Okay, and now let's go and break that down a little more. So 1, if position not 100, position equals 100, output number of rolls. Okay, if position has is in snakes and ladders, then we input as new a new starting point for next turn of possibilities. Okay, 3, if position already taken, ignore. We don't need to actually put this into our queue of the number of possibilities for the next roll. Number 3. So repeat step 2 until you reach position 100. And also, let's put this in sub quotes, sub bullet points. If you can't reach position 100, output -1. Okay, so with that in mind, the BFS has all these possibilities as listed from, like, when you start with a queue of all the turns of possibilities. It iterates through all the possibilities of those end positions to see what will be the next possibilities of where to start. But if it's not possible, then you can just ignore it. And if it's not possible at all to reach step 100, it'd be -1. Okay, that was a lot of planning. And I guess time and space complexity could be about O of n, because we need a bunch for snakes and ladders, but we also need to keep track of what is taken positions, and yeah, it could be up to O of n. I'd say the time complexity is about, it could be about O of n as well. N where it's O of 100, where, yeah, it could be about O of 100, because you have up to 100 squares that you might need to travel to. Well, if you guys have a better way of explaining, please put in the comments below. I had to say that I still have to improve my time and space complexity calculations, but let's just get right to the question. All right, so let's begin. I'm going to create a little more global variable to store the hash set and taken position. So let's see here. I'm going to need to do a minimum number of rolls. Start with 0. And by the way, for every time we do a turn of possibilities, I have to include this as a step right here, actually. Increment rolls, so that we're all on the same page. All right. And if it's not existent, we return -1. Okay. So in order to get these paths all set up and ready, Make sure I didn't miss anything actually. I think it's kind of ready. All right, so to make sure it's all ready, I first have to load the data, load paths of the ladders and snakes, so that it'll be easier to access later as a hash map. All right, so this loads the path and shortcuts, so that'll be easier to access. What will be the end position once you cross it? All right, and we'll need a queue, or I'm going to use a linked list. Maybe that's easier to work with. Teacher possibilities. Let's see, I'll call it possibilities equals new linked list. And call it integer. There we go. And since we're starting at space 1, I'm going to offer the first integer, and now we begin the iteration of each roll. So we'll start with while the possibility is empty. While it's not empty, we keep iterating. And let's see here. Now, I think there's something else I'm missing. Oh yeah, we have to increment the mid rolls, by the way, every turn. Now, for each of these, now we also have to take int num of possibilities. So let's just say the first turn is just 1 right now, because we only have 1 possibility of starting from the start. But later on, if once we add like 6 more possibilities, we have to go through that turn of 6 possibilities, and let's just say, you know, there might be 20 possibilities the next turn. We have to go through that whole turn of 20 possibilities to see where we can end up next. So I think, sorry about that, guys. I need to think about this. So I'll call it current roll equals possibility dot. So we start rolling to see if there's any possibilities that we can go through. All right, and next, once we start rolling, all right, so if the position plus, say current plus position is equal to 100, then we return the min rolls. That means we actually reached the position. Now, if that does not happen, what can we do? Let's see here. Did I initialize the taken? All right, I had to make sure I initialize the hash, some of this hash stuff here. So here I have to initialize the paths to create a hash map for that one. Paths equals new hash map. And I also have to initialize its taken steps. So now I have to check also if it's also within the paths. So if paths dot contains current plus position, then I think to make this easier than saying current plus position, did I use the variable turn yet? I would call it int new position. So this is the new position that it could possibly be, and if it contains that new position, also if it contains that new, if the path that contains that new position, then new position is equal to paths.get position. So we go to that shortcut area. We also want to, before we do that, we want to add to taken. We want to add this so that we know that we don't need to take a turn if it reaches that previous new position that was made. So now we're at a new position. Now we want to check if it doesn't contain that new position, then we'll definitely want to add this to the next possibilities of where to start next. So I'll call it pos.offer new position. So it's a new possibility of where to start. All right, and now we also need another condition. If this position is going to get greater than 100, we should stop also. Also, take it doesn't contain it, and then definitely we can offer it into the site of possibilities because we can't go past 100. So let's just. I need to walk back my code so I can understand what's going on to make sure I didn't miss anything. So here's what's going on. I start with minimum number of rolls, okay, and I load the paths of ladders and snakes with a hash map. The reason why I do that is that it'll be easier to index what will be the end positions once I land in those starting positions. And now for each turn, now we offer a first position where we start off with, which is 1. And since it's not empty, we increment that minimum number of rolls. So at the first turn, we're rolling once to see where we can go. Into number of positions equals position at size. So in this case, it's just only 1 right now. Turn equals 0. Turn is less than number of the possibilities. Okay, so we check all the possible turns that we can start off with, which in this case is just 1. And if integer that current, now we pull off the first possibility, which is 1 as a current position, and we start rolling to see if we could find how far it can go to reach step base 100. Now, if new position equals 100, return the minimum rolls. Okay. Also, path that contains the new position. And taken.add. So we add this new position to the steps I've taken. Okay, so we also have to add it here, guys, also to make sure that in our future rolls that we don't have any repeat positions. So first, now, if it contains that new position from the past, then we reassign it to that end position once you take that path, whether ladder or snake. But we also want to record that we don't want anything to roll at the starting point of that path ever. And if it doesn't contain that new position and it's still listed 100, we add it to steps I've taken so that no other future rolls can hit that same position. And also, we offer it as a new starting point for the next turns of possibilities. Okay, I think this looks fine. And if there's no possibilities, it's going to be empty of possibilities and it'll return -1. So let me run this code and see what happens. I think there's some syntax errors possible. Yeah, hash set. Ah, I see. I actually have to put new hash set. Maybe that's the reason why. Okay. And this one, instead for hash map, it has to use the method contains key instead of just contains. Oh, sorry. This is supposed to be just pause. Oh, spelling, man. Holy cow! No, wait. Slow down. Slow down. Don't still get excited. Let's submit and see if it works. Oh, what did I do wrong? What did I do wrong? Huh. This is the hard part, is debugging this. Now, usually when you're in your interviews, you're not supposed to run this and check if it's wrong. You're supposed to know this if you work through your code. Let me tell you why. What happens now? From the rules above here. I can't believe I fell for this again. I practiced this a while ago. And all right, so neither square 1 nor square 100 will be the starting point of a ladder or snake. I'm going to repeat that one more time if you get what I'm going. It would not be a starting point of a ladder or a snake. It doesn't mention it could be an end point. You know what that means, guys? Oh my gosh. I want to move things around a bit. Hold for a second. Here I'll put the condition right here, because if that means the endpoint could be at base 100. Let's see if this still works. I'll run the code once, and yep, it still passes. But now in this new position, if it is already in base 100, then we just return the min rolls. There you go, guys. That's how you solve snakes and ladders. If you have any questions, please list it in the comments below. And the reason why I put this right here is because, again, I'll repeat this one more time. This short path doesn't mean that it cannot start from base 1 and base 100. That's true. But if it starts on, the endpoints could end on exactly your goal. Therefore, you want to check to make sure, if you reach that one, just return the min rolls. Like if you have a ladder that goes from 2 to 100, then that basically in that roll, then you already reached the endpoint. So I hope you guys like this content. Please like and subscribe. And if you do, I'll send you a Snakes and Ladders video game, Activision version. It's Game of the Year award level content. It's going to be, as soon as you wake up, like almost you have that Christmas feeling. It's going to be like that. You just open your PlayStation and you see it right there. Yeah. I'm just kidding, guys. Take care. Have a healthy day.